Let's talk about gravitational potential energy. Now, this is the energy that you possess because of you are of a certain height above some point. And so, as we have mentioned before, if you are at a height, let's say h, you could potentially just fall off and gain kinetic energy. And so to gain kinetic energy, of course, you must have some energy at first, and we call that energy GPE. And we would be very aware that the change in GPE can be expressed as mg delta h, typically. Now, in the A levels, we must know how to derive this expression, mg delta h. And so to do that, let us consider a very simple example. So let's say we have a mass over here, m. Okay, we're going to exert a force F on it, and we're going to try to lift it over some vertical height h. And now, the only thing that we are allowed to use is the fact that the work done by a force is equal to the force times the distance moved in the direction of the force. So what we want to do, we want to make sure that the work done by this force F over here, okay, work done by F, is exactly equal to the change in the GPE of this mass m. Then I can equate the work done by this force to some expression for the change in GPE. So to ensure this, it is very important that this mass does not accelerate. And so that is because we want to make sure that the change in KE is 0. And so therefore the work done by the force F is purely equal to the change in GPE. So now we can say that the change in GPE is the work done by the force F, which is F times h. But to ensure that it does not accelerate, then this mass has to be in equilibrium. And so we know that there's a weight of the mass mg. And so if this mass is in equilibrium, then F has to equal to mg. And so therefore the change in GPE is just mg change in height.